Pardon? We are rolling. Contact. So, all right, now that we got all the AV stuff settled out, Ted, thank you very much, sir, handling every bit of that. What are you, his little bitch or something? Good grief, dude. Here, let me put the microphone in your face. Oh. Is there anything I could do for you, sir? Please let me sit on the edge of the stage. I'll do good stuff.
Move along.
Move along.
We got 90 slides.
I don't care.
Let's get
Trust
moving.
me, there are more things that have been done, recorded to me doing stupid stuff. T-shirts, come and get them. $15 cash donation to the EFF or the HFC gets you a T-shirt of your choice. Still most sizes left. They do have ladies and youth sizes as well. If you forgot to get something from the gift shop, you can grab a T-shirt for your kid. They'll be selling some of the bags if you guys have been to cons before. Huge amounts of bags. Well, unfortunately, Heidi and Bruce have a garage that's full of older bags. So they'll be selling last year's T-shirts and last year's bags at a discount if you didn't get enough of them then. They're doing a Python for newbies from 11 to 1 in the Columbia foyer, which is the chill-out area. That is Bill Pollock's son from No Starch Press. He's going to do the Python for newbies class. If you have feedback, please send it to feedback@shmoocon.org or feedback, or go to feedback.shmoocon.org or info@shmoocon.org or heidi@shmoo.org.com. The point is they want to hear from you. So if you got something to say, good, bad, or indifferent, please send them some information. Let them know how you feel about it. Visit the Hacker for Charities booth. The stuff finally arrived from Uganda. Did anyone actually, have they got a chance to order anything online before now? So it got lost in British Airways, and they like spent the day yesterday trying to track it down. So it finally came in. So if you've ordered something or you'd like to purchase what they've got, please stop by and check it out. So we're going to do some trivia. Come up with a good trivia question.
A good trivia question?
Yeah.
In the movie Tommy Boy, who is Richard's favorite little rascal? Spanky!
All right, good morning.
Richard also played for the Yankees, that's correct.
Let's see. All of my stuff is hacker movies, so no one ever gets the ones that I do.
I'm zero cool.
You are zero cool. But, all right, I'll ask this question every year until someone memorizes it. What's in the movie War Games, what's the launch code for the Whopper?
TKS 1704 CPE.
CPE 1704 TKS, but close enough, you've got all the digits. All righty then. Okay, here's the next one. What is the this mailing address of Stephen W. Falcon? Close enough for you.
Let's go.
Current DOD pension files indicate mailing address of Stephen W. Falcon, a.k.a. Robert Hume, 5 Tall Cedar Road, Goose Island, Oregon. Thank you very much. You got the next one. How much? That was my youth. It's not my adult life, I swear. We got 2 more objects. Yours.
2 more objects. What is BRO short for?
Big Brother.
Big Brother. There we go.
There we go. Take your pick.
Glass or card game? Card game.
Any other?
Go ahead.
That's shit.
Is anyone on this side of the room awake?
There we go. Thank you, Brett.
Excellent.
Good trivia.
So without further ado, and so I can get my coffee.
Who's gonna fix it?
Is that like L-I-M, like Will I Am, or is that
No, that's just like Liam.
just like Liam?
Just
Pronounced
Liam.
just like it. No
Just
inflection?
like that. Nope.
Ladies and gentlemen, Liam Randall, please. Thank you.
Okay, all right.
All right.
So if you've had an opportunity to talk to me in the last few days, I think that you'll know that my PowerPoint slides are not working. That is hilarious. There we go. All right, so this is me. I tap things. I generally tap all the things. You've probably met me at other conferences where I tap things and then show you BRO and BRO-IDS. I generally travel around a lot. On IRC, I'm Hectaman. And I've probably talked to half of you in either, somewhere on Freenode and Security Onion or in BRO-IDS if you've ever needed help. If you would like to live tweet today, please use hashtag BRO-IDS. If you want to go ahead and give me a follow, I'm at Hectaman, and the project is at BRO_IDS. All the code that we're going to be reviewing today is already live on GitHub. If you have your laptop out, please feel free to log on and clone my repository so we can do the live demos together. The main project website right now is bro-ids.org. Today we're going to cover a lot of things. We've got a lot of slides and information to go through, but we're going to be presenting why the hell do we hang out? There we go. All right. We're going to first cover all the Bro basics, then we're going to look at some applications, and then we're going to do some programming demos. That is what I think is the thing to be most excited about. The way that I teach Bro is not the way that everybody teaches Bro. It's not the only way to teach Bro. But Bro is kind of a hard thing to wrap your mind around. So it's somewhat an unfortunate name for an incredible product. It was named in 1994 and is short for the Orwellian Big Brother. And I hope the demos today clearly communicate the incredible power in the Bro model, which is the overall thing altogether. I think it's helpful to begin with the end in mind, though. So let's quickly just get the shape of the thing. Let's go ahead and drill down on some logs from BRO-IDS. BRO-IDS is only the first great application to be written in the Bro network programming language. And here's what it looks like. You get these highly structured protocol logs at each layer of the IP stack. So what we're doing is let's just start with all the HTTP logs. Okay? So what you're looking at here is a list of all the browsers that were dynamically pulled out of all the streams. And I'm using an interface here that's called ELSA. It's written by a brilliant guy named Martin Holstay. He was formerly in Wisconsin, was just hired at Mandiant. It's a great project. It's included in Security Onion as one of the interfaces for Bro. So now what we can do is, this is a list of, the count of, this is a big map reduce operation here. All right, that's what we're doing. But Bro is what generates this underlying data that we're looking at here. So let's browse down the list and say, oh wow, look, here's somebody that kind of cares about Java, but not that much. And we could drill down real quick and then generate a quick list of, here are all the people now in 2 clicks that are all the browsers. Now let's look at all the agents that are using this, and then we could do another map reduce, and then look at the source IP. I know that there's a lot of information crammed into this screen, and I just don't want you to worry about it for right now. We're going to look at the detailed protocol logs in a little bit detail later, but I just want you guys to kind of understand the idea of the thing. Bro has academic heritage, so it is very Unixy to begin with. I want to show you the native output of Bro, which looks like this. Let's just do here. Okay, so if you look at that, these are just highly structured logs. So these are similar to any of the other logs that you typically see in a Unix system, and they're very sed, awk, grep friendly. They're very easy to do things from the command line. Like here is a quick command that's going to take the NOTICE.LOG, which we're going to cover. We're going to go into this in more detail. I'm just trying to give you the end in mind. This is what we're looking at. The NOTICE.LOG, we just did a quick group by sort unique on all the alerts. So if you look at some of these alerts on screen, what you're seeing are notifications that there were downloads in the HTTP stream. And more importantly, that some of them were applications. And that some of those applications, the SHA-1 that Bro generates for you dynamically on the fly, matched the Team Comrie malware hash registry. All of this comes out of the box in BRO-IDS. So later, as you hear me talking about programming, just realize that the first thing that Bro is it's a programming language. And the Bro model is very important. But out of the box, you get this great thing called BRO-IDS. Whoops, I'm going to go back to the presentation. Okay, so there are plenty of different interfaces for Bro. I've done Bro deployments with Splunk, with ArcSight. There is a native project that we're working on with our Elasticsearch writer that's called Brownian. ELSA is the one I just demonstrated, and it's free in Security Onion. So don't focus on how I'm accessing all this information today, because I'm going to show you a lot of different ways to do it. Keep in mind the underlying tool set. When you think about all the tools that we currently use in NSM, there's generally a whole list of them. We have things like TCP dump, which is, all of our big data. We want to capture all the things. And then we have Wireshark, so we can decode all the protocols and, drill down in and see that, oh, well, what is the user agent string in an HTTP stream? We have Argus, which is, a connection record. It's who talked to who when did they talk, how much data, what ports were they on, those sorts of things. And then you'll have some Snorta Shurikata. This will be your alert data. You're going to download signatures and rules. And then you'll tie it all together, more importantly, with Python. Or Perl or some other scripting programming language. The neat thing about BRO is the BRO model is actually all of these tools all rolled into one. And I think it's easiest to think of BRO not just as this big amorphous blob, but my way of understanding it, and I think the easiest way to explain it is to explain it as three different things. Out of the box, we have BRO-IDS, the first great application written in the BRO network programming language. And this whole event-based model of programming that we're going to discuss today is called the BRO model. And what that is if you think about what would I want to know when I'm programming in a GUI? Well, I would want to know if you click on something, if you click on all the shit, then I would want to get an event. And what BRO does is every time there's a new TCP stream or a new UDP stream or a new DNS request, an event fires up into the air, and you can attach onto that. And we're going to go over this in detail. I'm just trying to, think about this is the journey that we're going to go on over the next 45 minutes together. And whenever you see these little Twitter tags, that might be a great thing to put out on Twitter if any of you guys are doing that. Just a minor suggestion. I've got a couple key phrases, and if you guys want to help echo that out through the Twittersphere or whatever we call that thing, that would be wonderful. So subtle hint there. So let's start at the top. Let's start with the first great application, because it's easy to see what a language can do when you look at the tools you can develop with it. BRO is a big thing. And let's think about where we put our BRO sensors here. So what you're kind of looking at here, I kind of divide the world into my two different kinds of clients. I have my corporate clients that lock all the things, right? Everything's locked down. You own the network. You can really restrict everything. Everybody's in Active Directory. You've got group policy. You've got all these things. You've only got limited exposure to the internet. On the complete other side of the continuum and spectrum here, you've got all these open access networks. Think like universities, research and education facilities, ISPs. These places over in the open access area are the traditional home of BRO, because BRO is developed at Berkeley. Its continuing team, the core team, is homed at the International Computer Science Institute, Berkeley, and the National Center for Supercomputing Applications. So this is a product that is developed by serious computer scientists. So that is why when you talk to some of the core team, they'll tell you about, when you ask them what is BRO, and they'll say, well, we're working on putting Bloom filters into BRO, which are a way to rapidly access and query large amounts of information. But I don't really think that helps to explain what BRO is. So I think it's easiest to look at the things we can do with BRO and to explain it by example and demonstration. So BRO's big deployment model has been in open access. In 2011, was a big year for BRO. It's because when BRO 2.0 came out, BRO is now really easy to build, very portable. There's a Jenkins server. The documentation is up to spec. It was incorporated right into Security Onion. So now there are BRO deployments all over the place. And there are even a bunch of magic boxes that are sold as Network Mojo, and really it's just a crippled BRO appliance. It's crippled because I really feel like the magic of BRO is in this amazing community that I would like to show you guys some of the things that we're doing in the community so that we can bring more of you into it. So let's look at what these taps do. Okay, so you have a line, and you can put BRO at multiple places in your network, but people usually start at the border. So you have a line, and we just take a feed. It could be a span port, although generally I'm a big fan of hard taps. I think that you get much better quality, you have less problems, and so forth. And you just take commodity hardware, commodity NICs. These are Dell R710s. These are super micro boxes. These are whatever your corporate networking policy group makes you buy, and you can install BRO on them on your choice of an operating system. And it does things. BRO is driven forward by the traffic on the wire. So we have all this traffic, just flying across. And BRO does all these neat things that we're going to show. It does dynamic protocol detection on everything. It speaks all the tunnels. And to you, we basically take away the concept of port, because we don't really care what port things are running on. You just want to know that it's HTTP or that it's SSL TLS. So we only use ports as one heuristic in our model in our dynamic protocol detector. The man who invented dynamic protocol detection published the first paper is Vern Paxson, the guy who started this project in 1994, before BRO was even a thing. So the first part is we have traffic pushing BRO forward. Then you come into this big BRO amorphous blob, and we're going to break this down a bit. And you have highly stateful. That means it tracks all the things. It tracks all of your TCP connections. It does mock UDP and ICMP flows. It tracks HTTP state. And we're going to look at some protocol state machines in a few minutes at a very high level. I'm a computer scientist by trade, but this is kind of what I do for a living. I do a lot of what I'm doing right now with you. This is what I do for corporations. And then we tap all the things. And there's all of these analysis frameworks. Frameworks are just a nice way, or a BRO language way of saying a library. Okay, you know, think of BRO as like a domain-specific Python. It's not Python, but it's a programming language that's specifically designed for network programming. And then BRO does stuff. It does three things. It does like an archive of what is on your network through detailed protocol logs at every layer. It does alerts, which would be something where you could think of like, these are things that we've detected that you might want to know about, like a heuristically detected series of SSH logon failures. Or that somebody just downloaded an executable, and when they did, the server said the MIME type was going to be an application, it was going to be a JPEG. You know, those are things that we drop out into the notice.log. And then the best thing about BRO is that because it's a Turing-complete programming language, fancy way of saying that you can build anything out of it, you can do things, and you can do anything you want. And I'm going to give you some code, and I've already put all this up on GitHub. If you've cloned my repository back there, you could be playing with that right now. So you can detect all these things and do all these things at the protocol level, and then do things with it. And that is a really neat model when you start to think about the kind of intel and active management you can apply to your network. So we're still in the BRO-IDS part up here, okay? We're in the top of the triangle, and what we're looking at is first, let's take a look at some of these highly structured logs. First, a quick little BRO note here. In BRO, there is no client and no server. That model doesn't really make sense. Those terms are not appropriate. And I think when you start to look through BRO, you'll see ORIG and RESP, which is just short for originator and responder. And it really makes sense when you start to dig deep into protocols and think about what's actually happening on the wired level. Does that make sense? Okay, so let's go ahead and look at some of these logs here. So BRO does all these things. It reads all the things, and then it does all the stuff. And then it has these three things that come out. We have these detailed protocol logs, which, for example, earlier we looked at the HTTP log. There's a DNS log, and there's an SSL log. There is an FTP log. And these logs are very, very highly correlated. For example, in the FTP log, as BRO tracks the state, it follows. If you issue a CD command, the BRO FTP analyzer will follow it. So then when it writes that one log line out for you, it's taken the two FTP channels, reassembled them, and also even prints the URL with the appropriate path. Even if you went in and changed all the way down the directories and all the way back up the directories, then back down again, it follows it and keeps the state of it. That is really neat when it just works like that. You know, you don't have to worry about how it does all that. It just does it. Alerts would be those things like the notice.log, and we're going to look at these things and more. These are just the three types of things, and then actions, as I've already mentioned. They could be protocol-specific actions. They could be actions on the data. BRO grabs an MD5 hash of all the files as they're going across, so you can look at some of the Intel examples that are already integrated. Or you could imagine your own, like, well, if I get the application, why don't I just send it right to Cuckoo Box and see what it does? That'd be neat to do. Or why don't I JS unpack all the things? Because I can. I mean, these are the things that we're playing with in BRO. And when I start to show you the examples, like today, I don't know if you caught it on Twitter, but I'm going to drop a Lucky 13 SSL detector. Because right now, we're all just hanging with our butts out in the wind because none of our programs are going to be patched until, May, depending on what you're using. There's a big patch schedule there. And to detect that attack in BRO is trivial. Absolutely trivial. And we're going to do that together. And actually, everyone who does tweet today's talk can be a co-author on it when we release it today. We'll actually push it to GitHub together. So if that isn't a little incentive to maybe follow BRO_IDS or @Hectoman and just give me a little shout, I don't know what is. You know, we're going to actually do science. So let's do that. All right? So let's start with a detailed protocol log. Okay, so I tried to make this as pretty as possible because, you know, Unixy output is sexy in a way, but it's kind of hard to look at. So I wanted to just sort of lay out kind of easily. So in your BRO logs, here's what you get on the protocol logs, because there's two types of logs, remember. All the protocol logs and then notice logs, which are the things. So you have a timestamp, which is Unixy. You get a UID, which is unique. So let's say we wanted to, if you look down this list here, over on the right, you see that there's the service string down at the back there. Okay, so this would be our fourth layer that we're looking at. Let's say we wanted to find, you know, for that HTTP session, the actual underlying TCP stream. We could just do a grep-rin and then that UID, and it will search through all the logs, and that UID is consistent through the stack for that event. And you can use some of the tool suites that are provided with BRO to do something like a bro-cut-d, and don't worry about the detail, and it'll actually go ahead and convert the epoch time to human readable. So if you're a Unixy kind of person, BRO is definitely for you. And if you're not a Unixy kind of person, you can plug it right into Splunk, or you can install Security Onion. It includes ELSA for free out of the box. That's actually what we're running here on the network. If you've been in the lab, you've kind of heard my sort of intro to this talk, and today we're going to just take that to a new level. But when I go and tap all the things, I generally just use Security Onion because it installs in 5 minutes. And it works. And all the tools are all right there that you need to deploy this on your network next week and start to have this stuff on commodity hardware. So this is the other side of this log here. So we're kind of continuing off this one long log here. So we kind of do these mock flows, and you get all the details here. An interesting column here is this history column, and we're going to come back to that in a little bit. The capital case letters and the lowercase letters just tell you what did the originator do and what did the responder do, which is great for detecting malware, because when we start to look at attacks, there are some neat things that we can detect based on some inappropriate behavior. And we'll come back to that in just a second. So don't worry about the details there. Here is the other type of log that you get in BRO. You have all the protocol logs, and now this would be an alert log. So these are notices. These are things where we're basically doing additional heuristics on the data to tell you things that we think you want to know. We have incredible depth and expertise in the SSL TLS space. And we're going to actually go deep on that in a few minutes here. But we also do things like detect all the software and tell you that, hey, because we're reading all of your plugins in your browser, I can tell you who's running outdated Java on your network, and I just drop it into a log. Because we have all the data of the sessions, we give you MD5s on everything. And in BRO 2.2, which comes out in a couple months, we're even going to abstract away from the idea of having a protocol or a file associated with a particular protocol. Right now, you get a protocol-specific event that you can attach onto. With the file analysis framework, you can just say, well, I don't care if it's on BitTorrent or HTTP or FTP or wherever it was, you'll get a new file event. And it'll say, hey, we have a new file. Do you really care where it came from? Maybe not, probably not. Send it to JSUnpack. Do whatever you want with it. Save it out here on a directory. In your network now, do you have a folder that has every executable that's come into your network? Does anybody have that now? You can do it in BRO, right? All you do is just enable one little flag and tell it what MIME types you want it to save out to disk. And you can just write them out there. I use it all the time. It is the greatest thing. And you can even start to do really smart things. So you could say, hey, when I see a user download malware bytes, I might want to open a ticket. Because that's a derivative value that we can kind of do some intel on. So I have a little query that I run on all the self-help sites. So when I see users start to do that, it actually tells me, because I know that so-and-so over there, Mr. Smarty Pants, is going to run malware bytes, and it's going to come back clean, and he's going to be, woo, that was a close one. Guess I don't need to call IT. Okay, so these are the notice logs again here. Again, this is just stretching out this long notice log. I wanted to try to make the letters big so you're not complaining about turn up the text, whatever. This is the other side. So you can see there's some detailed data here. And BRO is so huge, and I'm so in love with BRO that I could talk about it all day long. So if you want to continue this discussion later, I'm just going to go over to the lab. But I'm trying to give you a big survey almost of what's in BRO and selectively go deep. So I'm skipping over a lot of things. What about executables that come in on an SSL connection? Right now, we don't see what's going on. We do not have an SSL decryption library in there. It fits the model just fine, though, and it's maybe somewhere on the to-do list. I'm sure it will happen eventually. It's something that I would like to make a big priority. But right now, that doesn't happen. And then we have the actions. And I'm deliberately being vague here because we're going to do some actions here in a minute. There's a great documentation page up on the wiki. It also comes included in your BRO install called events.bif. It's a big listing of all these events you get for all the protocols. But again, I think that BRO-IDS is amazing, and it's great, and you should install it. But the really things to be excited about are the BRO network programming language and the BRO model. So let's talk a little bit about this BRO network programming language. We were here, and now we're down here. I think I'd actually do that in this slide. There we go. You are here. So it's, the language was developed as an academic research project in 1994 at Berkeley and LBL. Again, those academic roots really shine through in BRO. You know, everything, it's not just a scripting language, it's a Turing-complete scripting language. If you've worked with software that's not designed by serious software engineers, and we all have, maybe we've even designed some ourselves, there's a difference between people that know data structures and people that don't. And BRO really stands out in that regard. Okay, so let's talk about this BRO event model. Okay, earlier I said if you're programming for a GUI, what do you want to know? When somebody clicks on something, I want to know it. So let's take a mental map here, mental model, and let's apply that to networking. So we have all these things, and by the way, these aren't just the computers that are in Active Directory. Because we're a passive tap, this is all the things, right? If you're speaking IP and you're going across here, I don't care if you're a SCADA device, and we have SCADA analyzers, by the way. I don't care if you are a printer. So long as you're speaking the protocols that we speak, we're reading it. And I do a great job at showing people new ways to learn about their network with these tools. Okay, so we have all these things, and they're shooting traffic across the wire here. Let's look at what happens here. It comes across, and it comes into BRO here. And then what we have is we have this dynamic protocol detector. And what it does is it heuristically detects everything. So you have these network events that come in here, and here's what would happen. This is going to be in a TCP stream. So the TCP stream, we'd set up and track that connection, and then you would get all these TCP events that fire here. What I have hanging off these little bubbles here, this TCP packet, TCP options, TCP contents, HTTP reply, this stuff, these are sample events that you get into BRO. And we're going to look at events in a second so you can see what these kind of look like. So these requests come in, and it comes up, and it basically gets sucked in by the HTTP analyzer here. And it's going to go over and get put into my Stevie Wonder queue over here, and you'll see why that is in just a second. Okay, and it hangs out in something called an event queue. Okay, so this is kind of the traffic model, and all the other traffic comes over here. Okay, and it all gets dynamically detected, and you get your TCP events, pew pew. You get your UDP events, pew pew. And they're all just kind of flying through here. And you get a DNS reply event. Every time there's a DNS reply, it doesn't matter what kind of device sent it. So long as it is a DNS reply, we speak it. So you don't have to worry about, do I have a host-based agent for this or a host-based agent for that, or I can't even install stuff on my TV, which is basically a little Linux box, or my printer, or whatever it is. This model works. Okay, I fixed it. Good. So I couldn't fix my animation there. I'm not a real, graphics designer thing, whatever. But I like that little model. I thought that was kind of instructive. So you get all these events that get put into an event queue. And then what you have is you basically have all of these event handlers. So there's a specific event handler for each event. That kind of makes sense. And what you can do is you can hook each one of these events as many times as you want. So you can hook the HTTP request a dozen times if you want. And then what happens is that these events kind of fly through and they get serviced in this queue. The event handlers are executed in a priority kind of fashion here. So, and there's a lot of things I think that in the future will change in that as far as making things work better. And you can kind of see, look, they just sort of go through and they sort of fire off. You know, you guys, everybody kind of understand that model? Does that make sense? Okay, good. So the thing that I really love about Bro is I keep on saying, you know, it reads all the things. So I am very fortunate, and I get to work with some really amazing people. And one of the things that I always love showing people is how well Bro reads all the things. This is an actual PCAP that I have from a facility. And here is what Bro does at all the layers. I just want to kind of walk you through the Broception. So we have our Ethernet frames that come in, and they're 802.1q tagged. Then they're actually an IPv6 tunnel, which is speaking UDP to encode a GTP tunnel, which is a GPRS tunneling protocol. It may give you a hint into what industry this is. If not, I'm not going to tell you. And then we have IPv4 there, and then in that IPv4, we have the actual content that Bro is monitoring. And in Bro, you get a log for each one of these tunnels that pop, you know, Torito, AIA, 4 and 4, 6 and 4, 4 and 6, whatever it is that you have. And then you also still get this top of the HTTP event. And I actually have some better ones because a lot of Windows 7 computers will run Torito. So now on top of what you're just looking at there, add another Torito tunnel, you know, IPv4, Torito, and then IPv6. And I have never found another tool that can do anything like that. And to me, I just care that I'm looking at the HTTP data or the DNS data. I don't want to know how the network is actually provisioned there. I just need to detect all the things so I can do all the stuff, okay? So Bro, that is a very core competency for Bro, our protocol analyzers. So let's look at what do these events look like, okay? You do not need to be a rocket scientist to program in Bro. Bro is very user-friendly. This application is designed by the man who wrote Flex, which if you've written a compiler yourself, if there's any CS students here, you know what Flex is. This is the tool that's used to, one of the tools that's used to write other languages. So you will commonly hear that there are all these languages within Bro. These are not toy languages. These are serious, like academically sound, you know, Turing complete events. Okay, so let's look at this event here. So let's say we wanted to write, this is our event. If you look up at the record header there, you don't care how this is tunneled, how it gets to you. You just want to know that there is an SSL client hello event, which is at the beginning of an SSL TLS negotiation. Excuse me. So we get this information. We get the connection, which is just a data type with stuff in it. We get the version. We get the possible timestamp, the session ID, and then the ciphers, which is in that initial negotiation phase, you kind of exchange a list of ciphers that I support. It's a great way to probe networks because a lot of people support ciphers that they shouldn't, but that's neither here nor there. So if we wanted to write a detector for any SSL TLS questions that are version 2, does somebody want to take a crack at it? What is the programming language going to look like? Just pseudocode it for me. So we have the version, and we want to know if it's 2. What is that statement going to say? If version equals 2, great, you're all programmers. Congratulations, you can pick up your certificate on the way out the door. Okay, so you're right. If we wanted to write an SSL v2 version detector or an SSL v3 version detector, because you shouldn't be using that easier, the code actually just looks like this. If version equals SSL v2. And now you can program. That's it. Okay? So now let's build all the things. So this is a good example. Okay? So let's talk about these families of events here. Okay, so we have, for example, in HTTP, this is kind of hard to read, and if you can't read it, that's okay. Just know that in HTTP you have like a protocol state machine, and a grammar, which a grammar is just like what are the words of the language, and a state machine is when do the words happen. So if for SMTP, for example, if anybody's ever telnetted to an SMTP server, you know that you can't say RCPT2 until you say hello. Right? So in our state machine, you would have like a little flow chart here, and if you were designing a compiler for this language, you would build this state machine out of regexes and stuff. But all of these Bro events, because it's all stateful, all fire in order and in a predictable order. So for every HTTP request, does somebody want to guess what event you fire? Here, come get a jar here. You get an HTTP request event, and then you can do whatever you want. What I've basically done is to help you program faster, I'm releasing these things called the fire scripts today. And what they are is I'm basically grouping together all the protocol-specific events. So let's say you want to look at HTTP brute forcing or domain generation algorithms or whatever it is you want to look at. You take your PCAP and you replay it with my fire scripts here, and it just there's an order of them. First, I'll show you all the events that fire in order. So when you see that on screen, it goes, okay, and we're going to do that in just a second, maybe without sound effects because that was kind of bad. And then another one is just the sum total. Like, let's look at the count of each event, right? So let's do a quick example here so I can just show you what I'm talking about. Okay, so let's clear out bigger. That's what she said. Credits, Zach. You can come grab one up here. Here. Whoa. Can you all read that? I also suggest you get an eye check. Just for general suggestion. Okay, so I'm in a directory. Let's see what we got. Okay, so we got, let's look at some PCAPs. Oh, no, I'm sorry, I'm not there. Oh, this is where I want to be. Okay, so we've got some PCAPs here of stuff, and we don't know what this stuff is. So let's just look at them with some fire scripts. You know, we want to just kind of get the shape of the thing. This is an exploit or traffic or something like that. So from the command line, you can just do a BRO-C-R, which is read it in, and then the name of the PCAP that you want. Okay, and then I'm gonna just like do this nasty thing to get out to where I've got my fire scripts copied down here. I think I've got them out here somewhere. I don't know what layer of the inception network I'm at. Okay. And you've got all of these different events. So here is a little file that's going to just show you all of the SSL TLS events as they fire. And I'm running a lot of stuff on my VM here. So that is the order that those events happen. And that's all the SSL events in that PCAP. And if we did a bigger PCAP, it would just go beep, 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 all the way down the page, okay? And so now you know that you're looking at traffic. This is actually a good traffic sample. And we'll look at some bad traffic samples in a minute. And you can kind of see that even with simple, stupid metrics like show me the sum of the thing, the count of the thing, that stuff like HTTP brute forcing is like 5,000 standard deviations outside of normal. Right? And it's so easy to write a detector for these things. And I hope that you're going to see this and be like, wow, I could totally program. I mean, and I could make a difference doing it. And I'd like you guys to hop on Git, clone a repository, follow me on Twitter, tweet about this event, help me spread the message of Bro. So let's go back to our presentation. Actually, here, let's do another one. Let's look at the count of the things. Oh, not bro. It never ends. Bro. Okay, so this will just basically show you a count of each event. Okay, so these are the fire scripts. They're up on GitHub. Go ahead. So we know that there was one SSL client hello, and there was one X509 certificate exchange, and there was one SSL session established. Okay, that sounds like that's normal, and that is normal. But those are what events look like. So let's think about the things that we can then do with Bro. So we know all the data, we know all the browser versions, we know real-time activity like somebody just downloaded an executable from this ASN or this IP address or this network or this domain name, a .cc. So why don't we do some things in real time? Why don't we react on stuff? And I've already put this on GitHub for you. We could do things like, well, if I detect that you're running an out-of-date Java, and remember, this isn't just for all the devices I've got in System Center now, or all the devices that Nmap has Nessus has a plugin for if you're a NAC kind of person. Because I read all the things, if you're not using the right version of Java or SSL, you're banned. You go over here in the corner until somebody figures out a way to replace you. Because if that's the policy, and that's what we need to enforce, we're going to enforce it everywhere. And maybe not just on the devices that are in System Center and say, well, you know, we had to put so-and-so's iPad on or so-and-so's TV on the network or whatever it is. If that's the policy and that's what we need to defend against, then that's what we can do in BRO. Because remember, we know all the things. Okay, so what does this kind of look like? So BRO gives you a piece of intel, and you feed it back into BRO, and you manage your network actively. And this is really easy to do in BRO, and so what I did is I did a different demo, because I don't want this to become a talk about how do you use Google's Caprica, or what's that Python library that somebody released for managing routers and switches? Terry, didn't you tell me about it? Trigger. You know, I don't want to talk about Trigger right now. I mean, I just want to keep this about BRO. So I did a fun little a demo where I basically built a Twitter plugin for BRO. So on the network, we can have BRO tweet all the things. Okay, so let's take a look. So, all right. So remember now, we have scary amounts of intel in BRO because BRO is very powerful. So we could do all kinds of fun stuff here. Update Twitter. Now, a quick note to the demo gods, wherever you may be. Let's just hope that, Matt, your network is still in good working order and this works. If not, you can laugh. Okay, so what I've got here is a little PCAP of, I'm just going to delete the logs out of here so you can see what I've got. I've got a little SSH log on. And I've got a little Twitter script here. Let me pull up my code editor. All right, I've got my little update Twitter script here that just calls a command line client. Because what I wanted to give you is here's how you make BRO do something else. And now I don't really care what you guys do with it. You know, make it update your router, you know, push a BGP route. That was a request that somebody discussed. I thought that was a great idea. Let's make BRO do something, okay? So we're just going to do we're going to tell BRO to manually read this from the command line. And here's our there, and we're going to go ahead and call my little update Twitter script. Oh, wait, you know what? That's not going to work. Hold on. Okay. Thank you. .bro. Okay, so let's see if BRO tweets. Oh, there it was. Here. Okay, here's ShmooBot. All right, ShmooBot. All right, F5, go. Let's see. Did we tweet? Come on, demo, go. Let's click the refresh button. And we're not tweeting. Let's see why. Dope. All right, hold on here. That's what you get for changing your code right before you do a talk. All right, let's just have it detect. I was actually telling it to tweet other things as well for someone else I was playing with. And now let's try again. Attempt 2. I think I get 2 tries, don't I? And then I have to do a shot or something? Oh, schmooballs? Oh, no. All right. So let's see if BRO successfully tweets. So I kind of have my machine here. I'm running all those user interfaces and the MapReduce stuff all here on like, you know, a dozen VMs. So please be patient because I'm melting my laptop to the ground. BRO is actually normally very, very fast. It actually runs at wire speed at 40 gigabits at a lot of places. 10 gigabits is you know, a regular day for BRO. So if you think you have big data problems or big challenges or you have trouble finding stuff that will work at those kind of speeds, BRO is for you because it's already doing that. There are actually plans this year and testing going on to do BRO at 100 gig. Okay, all right, well, it has failed. I may not be getting out or something. Let's see here. Okay, well.
Network's down.
Let's see here. Okay, so we'll skip that again. I tell you what, I'll fire it off one more time, and if it doesn't work, we'll just kind of skip it and come back to it. Or we won't come back to it. No. Okay. All right, so I failed at demoing. It works, though. You can see on the update Twitter bot. Come in the lab, and I'll see what's wrong there later. Okay. Did that one work? Okay, all right, well, there we go. Work. Yay! Here. There we go, 19 seconds ago. All right, it did work. So I just have some weird error message coming out the screen now. Okay, so Bro knows all the things, it does all the stuff. Okay, so let's talk about Intel. So everybody has Intel. We have open source Intel. We have, if you're a special person, maybe you get special Intel, maybe generate your own. Bro can suck all this in. And the great thing about Bro is that it's not just going to test it on HTTP or SMTP. You can have Bro test all the Intel at all the places. So you can take DNS names, IPv4, IPv6, geospatial stuff isn't there yet, but that is a cool thing that we like to show as a demo to people because we read all the things, so why not look at EXIF tags and stuff like that. Hashes. Implementations that we already have are this SSL notary and the Team Comrie database. Here's how it works. You have all the Intel, it comes in. There's an interesting project that are used by some Bro communities called the Collective Intelligence Framework. It's open source, it's sponsored by Ren Isaac. It is basically like a big intelligence management platform. It includes out of the box, it'll suck in all these open source feeds. It's managed by a guy named Wes Young. Come join us at channel SIF over on Freenode. He's a good guy, it's a good project. There's also bash scripts that you can use to do all this kind of stuff. You can pull it in, and then you can do what you want. You can update Twitter with it. You could say, hey, look, we talked to somebody on the list. Or you can do whatever you want. I don't care. So that is your common intelligence. But I think that is something that Bro does, but I think that there's more that we could do. Because for every signature hacking away at the leaves of evil, there is a greater heuristic striking at its root, okay? So this is the difference between managing a list of people that do SSH brute forcing and a simple heuristic in Bro to say that if you have more than 5 SSH logon failures in a row, you're out of here, Heuristic, signature. I don't want to get into the whole argument about what's a signature, what's not, but generally I want you to understand that Bro can do regular signatures like your traditional IDS products just fine. But Bro's real magic is in doing all these other things. And BRO-IDS, the first great application written in the Bro networking programming language, tweet, is another thing that you kind of get there. So I called that Liam's Law. I went back and forth on that. I don't know. We'll see if that sticks or not. So file extraction. Over on the right, that's what the configuration looks like to have Bro save all your FTP stuff to disk. And I'll put up a blog post about this and do a video to walk you through, okay, I installed Security Engine, now what do I do to do all the stuff that Liam was talking about? And I'll walk you through this. But because you get all the files, you can start to do things like lookups to Team Comrie. You can do active analysis. I kind of try to think of this as the Christmas story of Bro, the Bromas story, if you will. This is the past, the present, the future, and the things that may be, okay? So in the past, we have all of our Intel that we already know. We have our signature analysis. We have Team Comrie, we've got Intel comparisons, then we have the present. This is active analysis. Why don't we take every executable and put it in Cuckoo Box or put it in JS Unpack, the present, okay? And then we have the future, long-term analysis, coverage for mobile devices, post-compromise, and analysis. Where's your directory of every executable in your company? Isn't that something you should have? Should you check a list and say, do I have this hash in my list? If I have to support this, if somebody's running this in my network, I'm in security. I should probably get a copy. Somebody just CC me on that because I know that happens right now. You get everybody requests everything and it just happens that way. I know it doesn't. And then predicate analysis. I gave my example earlier about every time I see somebody, I have a little custom script, anytime I see somebody download malware bytes, I get an email. I want to know that somebody's telling me that I'm in trouble, help me. Because malware bytes is probably going to come back clean on a lot of this stuff. And that is that's a derivative Intel value that you're losing. That would be another great thing to tweet. I should have done that. Derivative values in Bro or something like that. This is my favorite topic, okay? Not just my favorite topic, but I think this is a wonderful use case and example for Bro. What we've got here are all these incredible SSL TLS events. And remember, I could pick any of the protocol analyzers and talk you through things we could do. I picked this one for a reason. A couple of reasons, actually. Everybody knows that SSL is broken. We don't need to talk about all the examples. There are 651 organizations that can sign all the things, and 52 of them are under direct control of governments. And those governments are not all friendly. And some of us may have PCAPs of people doing things that they probably shouldn't. Maybe you see that. Maybe you work in those environments where that's a concern. Well, in Bro, you can do things like sign all the certs. Sign them all back to root. Since 7 or 8 CAs actually control, 99.9% of all the market, wouldn't you really want to know if I see any CA that's from anybody but those? This is an if statement in BRO, right? This is a simple if. This is a case statement. I'll put that demo out up on GitHub for you, because I think that's a good one. Because remember, the CAs are not the final target. You are, or your friends are, or your clients are, is what I suspect. NIST is jumping on board, and they're warning that CA is completely done. We're toast. You're all screwed. If you read these advisories, sometimes I feel like I'm the only one that does. We're in big trouble. Here is an example. Which one of these do you trust? Somebody guess. The one on the right, and I think you guessed correctly. No, you fail, but you can still have a cherry. You can still have one. Come on up and grab one, please. There are also all these other known attacks. You have all these devices. There's this great project that has all of this like SSL best practices, and I should make that into a bro script so you can just run it and say like, this is bad, but there are certs that you shouldn't use. There are all these things that we should be controlling against. And there are people that recognize this. Marlon Moxie Spike, he has his hold convergence. Carnegie Mellon has a project certificate. And what's the big problem with all these? They leave out a huge percentage of the market because they're only addressing the issue in browsers. When you look at when you run Bro and you look at your SSL log, you're like, SSL's used all these places? Like, our VPN is SSL TLS? I didn't know that. Maybe you did, maybe you didn't. But it's also used in mail, it's used in VPNs. DLTS is, DTSL is used in UDP devices. So this is used all over the place. And you're not going to install certificate patrol on your phone. Maybe you are you? Does anyone have certificate patrol running on your phone? On your SIP phone? Okay, good. Nobody has it. So in Bro, because we read all the things, that business process that's managing, $1 billion worth of your business through Ariba automatically, which is some crappy ASP.NET application that was put in 2001, and somebody bought one of those 100-year certs that's running, 512-bit, whatever it is, you get to see these things, and you get this intel right away. So this has wide applicability everywhere. And these other things I would like to demo, but we're running short on time. In Bro, there's scripts out there to look at the registrars, look at the CA, sign everything back to root. So we should look at those things. You get all this insight, and one of the projects that the Bro team has stood up is a certificate notary that tells you when an SSL cert has been seen before. That's a useful piece of intel. Pops out right in your log. Have we seen it before? When was the last time we saw it? Check it out. It's included. It'll be included by default in Bro 2.2. SSL is also really hard. Beast, Crime, and Lucky 13. Okay, we're on a roll here of serious SSL attacks. I did not think that Beast and Crime were all that serious. Beast especially because you need a malware-based agent. But I do think that Lucky 13 is something you should be concerned about. That's my opinion, and take it for whatever it's worth. It works everywhere. Most people are vulnerable to it, and there's no patch. So let's do, who wants to be a programmer? I'm gonna show you the fire script output from 4 different SSL TLS vulnerabilities, and I want you to guess which one is a copy of the Lucky 13 attack. And a big thank you to the authors. I had your names written down, but I left them in my backpack. Thank you. Okay, so you've got 1, 2, 3, and 4. Look at those SSL counts and let me know, do any of these things stand out? Take your time, 4, okay, number 4, and let's see what the answers are. The first one is a Gmail, the second one is a Google+, a VPN, and Tommy Boy. Because I'm not, in Bro, it's just like, it's not really over here, it's not down here, it's right here is where the problem is, right? These simple metrics, and this is not like, doing the standard deviation or complex flow analysis. Just looking at these things works. So up on Git, I just posted, well, I will post. I wanted to do it live right now, do a Git commit, but we're running short on time. I wrote a little detect Lucky 13 threshold detector. And the first heuristic is, when you're looking at that traffic, is, and this is like 25 lines of Bro code, the first heuristic is, and this is, by the way, the first time anywhere on the planet that anyone's doing that. So I'm protecting you guys for the next 3 months until you get all your patches installed on all your SCADA devices that I'm sure you're going to get a new firmware for. Right. Yeah. It's out there. Take a look at it, and we can have a good time. I'm at Hectaman on Twitter, BRO_IDS. I do have a couple more slides. We can try to just jam through these. You know, take those simple metrics and think about things like brute forcing, HTTP. It stands out like a sore thumb. You can just monitoring status codes gives me all kind of great intel. 500 counts for my servers, overloaded, maybe configuration problem. High 404s could be distributed scanning. Could be a direct dirbuster attack. It stands out. So in the next year, we're going to start weaponizing all this intel. This simple intel, like a simple script that is count this thing and then do that thing, right? We can all do that. It's really easy. I look forward to seeing you guys on the mailing list, up on IRC, and up on Twitter. So we have some time. So maybe a minute or two left for questions. Okay, let's go ahead. Go ahead. Has BRO been submitted to common criteria for evaluation? I have no idea. I'll check.
Is there a book to learn the BRO language?
There is a book coming out to learn part of the BRO language that'll be out this summer called Applied NSM. Me and Chris Sanders and Jason Smith. But more incredibly, the documentation is very complete online. And I'm going to be doing a series of blog posts to help you guys get into programming. I will commit the slides to GitHub this afternoon. So hop on, follow me on Git, clone my repo. Matt. Last one. Take someone else. Go ahead, in the back. Cool story, bro. All right, good ending. Thank you. I will be heading over to the lab for an hour. If you'd like to follow up and touch base, I'll be around all day, so come find me. Thank you guys all very much. Pew, pew, pew. How'd it go? Well, okay? Great. Yeah.
I got a quick question.
Yeah.
Is Open Certificate Status Protocol supported as part of the SSL stuff?
How do you do lookups?
For like the certificate replication?
Yeah. Yes. You sign everything back to. You can sign everything back to root. So you can actually take the chains and follow them all the way to the end.
Okay.
Yes. We speak Microsoft DNS.
Not Microsoft DNS. I'm talking ISO lines where you've got 1,000 lines, 1,000 information, and they're all doing different DNS searches.
It fits the model. It fits the model just fine. I will need to check on the detailed status of support. There's hundreds of protocols in BRO. So.
We're talking 300 gigabytes. It's 300 gigabytes long, 4 days of traffic.
Yeah.
Awesome.
Hey, you're welcome. Yeah.
Nice job.
Hey, did you like it?
It was good.
Did it flow okay? I was really nervous. I don't know if you guys can tell.
No.
All right.
I couldn't see you, so I gotta get my eyes.
Yeah, that's right. That's right.
So who's doing the
I don't want to say.
Sergey, should we try the demo?
Sure.
Yeah, it is up on the chill out area.
Sergey, can you give me power?
It's over right better.
Oh, back where the key,
We'll have to swap laptops
Yes.
because this thing is quite. Question. No, that probably won't extend. That won't extend. We'll swap laptops.
Let's still try it though, just to see if it actually.
No, do the blinky. Do the blinky. Do the blinky. Do the blinky.
Probably needs to be plugged in before.
Yes.
So I'll go through announcements real quick while we're getting ready here. T-shirts, please come get T-shirts. There's still lots left on most sizes, so don't make us take them home. For every T-shirt, there is a donation to either EFF or Hackers for Charity, your choice. We also have ladies and youth sizes left as well. We are selling bags from this year and previous years also for a donation. If you have feedback, send it to feedback@shmoocon.org or info@shmoocon.org or heidi@shmoo.com, or go to the website feedback.shmoocon.org. We really want to hear from you. That's why there's 4 ways to make it happen. Please visit the Hackers for Charity booth. There are a bunch of things that Johnny had wanted to get in from Uganda, and they arrived yesterday. So there's a lot of really cool stuff that he's got that is available right now and wasn't available yesterday, and don't make him have to take it back to Uganda.
Yeah, that would be cruel.
Buy DVDs from Ted. Ted does a great thing for us. He does all of the filming, lets us do the streaming, lets us put things up on the web for free. He makes his living doing this. So if there's anything that you really want to show to somebody else, go buy it and stuff it under them. I often do things like look at the 1 or 2 talks that I want somebody at work to see, so I buy them and then I expense them. Great idea. Also have some things to give away. T-shirt. I've got a Shmoo. The very dangerous scraper, which I won't. Nobody wants it. All right, back there. Whoa, excellent. I didn't kill anyone. All right, to there. And Skydog Con. There we go. Are we, AV, are we ready? All right. This is great talk. This is my favorite talk of all of the submissions. If you were at the open plenary on Friday night and there was discussion going around of what you thought was the most creative thing in the last 10 years, this is my vote for the most creative thing that I've seen in the last 10 years. So this is the Page Fault Liberation Army. They're not quite ready. All right, so I will keep talking. All right.
Howdy, y'all. This is so fucking cool. So, that's a technical term, by the way. So, when you've got a computer, you have other computers inside of it. And we're used to finding things like the Java virtual machine and seeing those as these extra computers and these extra programming languages that are not quite native code but behave in the same way. So it's very easy to build a program that compiles toward Java instead of toward x86 and then run it that way. But that's not the only place. And these virtual machines also happen accidentally. So while Java was designed to be a virtual machine, there are other places inside of your computer and other file formats that are also Turing complete, but not intentionally. The designers screwed up and made something so complicated that you can build a computer out of it. And what these 2 neighbors have done is they've found a computer in the page fault handler of x86 in which no x86 instruction ever successfully runs.